Hey folks, it's Rob Flux here with another Sunday session, and today we're going to be talking all about energy efficient builds and I guess the fact that they're not as expensive as you think. And the reason why we're starting to talk about that is there's massive changes coming in the National Construction Code, which is going to change the standard of all the buildings that we're going to have to build in the not too distant future. And there's a lot of fear as to what that's actually going to involve in order to do that, especially given that we've got a whole bunch of designs that might be out there that may or may not be as energy as efficient as we would like. Now, in order to have this conversation, we're going to introduce Simone Schenkel from Gruen Architecture, who is an absolute expert in everything, I guess, from an energy efficient design perspective, and also a thing called passive house. So firstly, Simone, welcome.
Thanks so much for having me here.
That's okay. So firstly, tell us a little bit about, I guess, yourself, Simone, and Gruen Architecture, and what it is that you guys actually specialize in, and why you are the expert that I want to be talking to today about this topic.
Yeah, so I think I've always been a little bit of a hippie at heart. So I've grown up in Germany, and I always watched nature documentaries with my mom, and I could never understand why someone could harm our nature or the animals. I guess that's how it started a bit. I studied architecture in Germany and then came to Australia in 2007. And everyone told me, you don't need double glazing, you don't need much insulation, it's warm here. And I half froze to death in my first apartment. And I wondered what the hell is going on here. And then I still remember I went to some talks in the city about the best and newest inventions in sustainable design. And that's when I thought, hold on, nothing's new about that. That's what I learned at university. And then I realized that my education was actually quite different, or, that all of the things I learned about energy efficient, sustainable design has not been taught here, or, was not taught here.
That's because you did architecture in Germany, yes?
Yes, yeah. And it was completely different. And, Germany, it's cold, it's freezing. If you think about Australia, if a house is done badly, it gets a bit cold inside. In Germany, if a house is done badly, you might get humidity inside a wall. And if the temperature falls below zero, actually the water might freeze inside the wall, and then your wall might crack and the house might collapse and people might die. So there is a big emphasis on building physics and building high-performing homes because we just have to. It's just a different way of thinking and studying. But anyway, so back then I was really lucky that my first boss, he loved everything German. He was a developer as well, so he had employed me to help him with the designs. And yeah, he loved everything German and German efficiency. And, I talked with him about it. I think, my knowledge is quite unique compared to in Australia. And he was straight away on board, and we started to promoting designs the German way and building the German way and more energy efficient. So that's how that all started. And then I got more and more into it and studied more about sustainable design. And after that, I worked with a design architect firm in Australia that has been doing passive solar design homes for a long time. So, I learned then on top on how things were doing it in Australia, which was a bit different to how we've done it in Europe. And then, in 2010, I started my own business as a side gig. And back then I was mainly doing energy ratings, like a lot, working with lots of our designers, architects, been seeing what they've been doing and struggling with. Started doing some small renovations, extensions. And then, in 2013, I had big goals and dreams and went on my own. Only to find out a week later I was pregnant. And then I had my second daughter 19 months later. The first few years went by a bit in slow motion, just working part-time with a few contractors. And then I think, in 2017 is when it started in, more seriously, when I got my first office, my first full-time employee. And since then we've constantly grown. So we're sitting now at 15. And we have a team member in Sydney, one in Hervey Bay, one on the Sunshine Coast. And over the time we grew in team in what we were doing. Originally we started with single residential and, small townhouse developments. But now we're doing social housing, special disability housing, core housing, and, bigger commercial projects as well.
Yeah, well, all of that, I guess bringing all of those experience from Germany in, I guess, the energy efficient side of things, to the point where you've actually named your business Gruen Architecture. So what does Gruen Architecture actually mean?
Yeah, so Gruen. Yeah, green is the German word for the color green. So it kind of means green architecture, which is, what we're doing. And it shows that the German thing And there's a bit of a fun thing with our logo. We actually have the U, the U with the dots. And there has been so much discussion with people, but you can't put it on your website. You have to put it UE. Don't you want to change your logo to UE? It's like, oh, no, we can't. It's a German word. I have to stay true to the German. So it's always a bit of a sticking point.
Well, there's the other Gruen that many people might actually know about, which is the TV show, which is all about advertising. That's I guess has a different meaning there. That's actually a gentleman that's actually named after. So that's see how good my trivia is. It's actually originally the show was called Gruen Transfer because it's the transition between the outside and the inside, and you actually want to trap people inside a shopping center and give them that experience. So yes, so Mr. Gruen found a way to make that happen.
Yeah, and funny that you just said that, because we went through the process of getting our name trademarked, and Gruen, could refer to the Gruen transfer, and therefore we could only get the Gruen trademark for the residential sector, because if you're not allowed to actually trademark Gruen for commercial sector because there is the Gruen transfer. So that was quite some interesting discussions with the trademark people.
There you go. So all of that, we're here to talk about, I guess, the energy efficiency side of things, and more specifically because of the changes that are happening in what some people will call the NCC, but it's the National Construction Code. So that is a national standard that we are all meant to be, I'm going to say meant to be, building to across the country. Okay, now each state will be rolling that out in different phases and taking up elements of that. There's a whole bunch of things that are being pushed back in some elements of that. But predominantly, the changes in these standards are bringing about half a dozen massive impacts to us, one of which is going from a 6-star to a 7-star energy efficiency rating. But there's also a whole bunch of other things in there. What are some of the other changes that you're aware of that you're seeing in your practice?
Yes, so the one big thing, especially for Victoria, is the livable housing standard. And I must say, New South Wales is kind of lucky in the sense that it hasn't been applied there. So these changes are actually quite big, that they will impact on, a step-free dwelling entrance. And that there actually be quite a few challenges. So I don't want to go into detail. That's quite nitty-gritty. But, entrance doors have to be made wider, and internal doors have to be made wider, and corridor widths must have the clear 1 meter clearance. And, there are rules around toilet doors and whatnot. So it is quite a lot, and I would recommend people to look into it early on.
Yeah, and that's predominantly around, I guess, a combination of aging in place and also a combination of, I guess, disability access and being, I guess, more equitable to all. So that, if you have a Zimmer frame, you need to get a wider door frame. If you need a wheelchair, you need a wider door frame, all those sorts of things. So making that, I guess, a little bit more acceptable and more part of standard living. But that's not the bit that we're here to talk about today. What we're here to talk about today is the 7-star. So let's firstly, we were previously 6-star, and they're making us go to 7-star. What is the difference between them not from a implementation perspective, but from a pure energy efficiency rating? How much difference does that happen, I guess, impact our house?
Yeah. So the interesting thing is that the lower the star rating, the more impact it has to go to the next star. So, if you go from 3 to 4 stars, I think you save like 60-70% on your energy bills. And still, if you go from 6 to 7, you save about 50% on your energy bills. Funnily enough, the higher it gets, so if you go from 7 to 8, I think it's only 25% saving. And then from 8 to 9, it might be 10% saving. Don't quote me exactly. It's not exact numbers, but definitely the saving get less. But I think one thing what I want to say as well, with the 6 and the 7 stars, many people are, probably really afraid about it, that it might be more expensive. But the one thing is the 6-star standard has been in place for over 10 years. And funnily enough, when the 5-star came to 6 stars, the exactly same thing happened. Everyone was scared, as everyone thought, oh my God, we will never be able to do this. It will be way too expensive. And that was exactly the time back then when I was doing all the energy ratings at the start, and I was dealing with so many designers and architects that were just struggling so much to get to the 6 stars. And I guess, it's a similar thing. It's a bit fear-based, but If you do it rightly, actually, it doesn't have to be hard, and it doesn't have to cost much more, if at all.
And we're going to go through a lot of that, I guess, today to try and give those architects who are afraid, or the I guess developers that are trying to, I guess, do their budgets and that sort of thing, give them some insights into how we can do this a little bit more cost effectively. And it doesn't have to cost the earth. But as you said, a 50% saving in the energy efficiency of the building means, I guess, cheaper electricity, cheaper cooling, cheaper, everything starts to come into play. So any incremental cost in the implementation is saved so quickly just from the actual running of the building.
Yeah. And I totally understand, as an owner occupier, it's really important for you that you don't have many bills. On the other hand, if you have a developer, for them, it's rather we want to sell the houses, we want to make a profit. It's a bit of a, obviously different angles you come across. But what we see as well, that in the market, more and more people demand better homes. People are getting more aware, what 6 and 7 star is. And for many, many years, there have been talks about that there needs to be mandatory ratings on any rentals or sales of homes. And Canberra has it already for quite a while, and it has proven there that houses with higher star ratings, sell much faster and sell for a premium. And, there's still lots of talks for New South Wales and Victoria. It's not there yet, but, at one stage it will come.
Yeah, well, in the commercial space, it's mandatory, what they call the neighbours rating. Okay. So, it's... I can see that eventually that's going to become part of the process, that there is a rating applied, and that the energy efficiency rating, I believe, will actually become a saleable item. So if you are a 6-star older style home versus a 7-star newer style home, I think that you'll actually get the premium for the product, because it is, well, firstly, it's more comfortable to live in, and then secondly, it's more efficient to actually run. So, and we're not that far away, but as you said, there's pain in the change. So let's see if we can try and soften, I guess, some of the pain of that change. So, and I guess the point of the 7-star is it's not a point solution. It's rather taking the whole house holistically and actually saying, well, we don't want to look at individual elements, but how does this actually work from a collective perspective? But to do that, the actual rating system itself, let's talk about the rating system and how is a house actually assessed? So if we want to get our 7-star rating, like, what is the process that the building certifier or the building surveyor, depending upon the state you're in, what's the process they have to go through in order to get that rating?
Yeah. So I think that the typical process, what people used to do, is that the energy rating was kind of just a tick, a thing you need to do to get your permits. So what people would do is, you do your designs, you do your plans, you get everything sorted, and then you try to get a tick. And which is, not going to happen in the future anymore, but I'm going to talk about that shortly. But how the rating actually works is like, the energy rater kind of takes the PDF, puts it into the NAFAS rating, the rating program, and then you kind of trace the floor plan. You put in all the rooms where they are, and you select the walls, and you select your wall types, your insulation, you put in your windows, you put in your eaves and your roof, and again, insulation and shading and what your neighbors do. And then the program simulates, what your efficiency is. And then the other big thing that comes into play with the 7-star rating is that it actually looks at the whole of house performance. So what you can actually now do is you can trial out and see how is my house carbon neutral, or actually how much energy do I need for the house, which can be quite good, I think, if you sell homes as well, or if you're owner occupier. So you can put in, say, your solar panels, how much power actually are your solar panels producing, and can the electricity produced offset your heating and cooling bills? So there are quite a few cool things you can do with that as well.
Yeah. So, but in doing so, my understanding is, whilst you plug it into the software, it's a theoretical rating. So yes. Once you've got the theoretical tick in the box and you've got your certificate from a design perspective, at the point of implementation, does anyone go back and actually sanity check that you actually built to the standard?
Yes, so that's my kind of pet thing, and I have to be careful that I don't go down a rabbit hole too deep, so I have to stop me. So yeah, the biggest problem actually, I think, in the Australian construction industry, that energy rating or energy efficiency is just assessed theoretically. Like you said, you have the energy rating on paper, but the sad thing is, no matter if you have a 7-star or 10-star home, no one is actually responsible to check how it's built. So, even though the documentations, the plans, the National Construction Code, everything assumes, insulation is installed properly, windows are installed properly, the house is somewhat installed airtight, no one checks it. So neither the builder, designer, architect, building surveyor. In theory, as that as it is, no one cares. And there have been done many tests from the CSIRO of existing homes, hundreds of homes, so-called 6 or 7-star homes, that actually performed like 2, 3 or 4-star homes, which is quite shocking.
Yeah, so I want to be clear just from anyone listening to this. Look, people are actually checking that the houses are built to the construction standard, but what you're saying is they're not looking at the energy efficiency standard. So yes, it's going to be built safely. It's not going to blow over in the wind, all those sorts of things. But whether the insulation has been stacked appropriately inside the wall, that's not a, I guess not, there's no actual formal process for that at this point in time.
Sadly not. And the reality of things is that often, say the insulation is installed and then your electrician comes and they have to pull in the cable and they just pull out the insulation and then, let's just fix the plasterboard quickly. Or, similar, you have penetrations for your plumbing or something, or for your heating, and the insulation gets pulled away and it doesn't get sealed, no one looks after it, no one cares or no one knows. But I think the sad thing is that, people don't want to do bad things. People don't do this because they want to build inefficient homes or, or they want to screw over the developer or the owner. It's just a lack of knowledge. Most people just don't know what impact it has if a bit of insulation is missing. So say if, for instance, if 5% of your insulation is missing somewhere, you're losing 50% of your heating and cooling capabilities, 50%. And, imagine that sadly what happens everywhere in most Australian construction sites, that there are just little gaps everywhere.
There you go. So pay attention at the point of implementation, folks, because you're in charge of what's actually getting built. So let's take a look at dive into a little bit of what actually goes into the rating system itself. So what are the key factors that change whether or not the rating actually gets higher or lower? So clearly, and one of the ones that are coming into prominence with the changes to the National Construction Code is the alignment of the house to the sun, so positioning of the sun. Yeah. So what's good, what's bad? But I'm hearing the place that north-south is the only way to fly.
Yeah, so I think that is where it will come to a big shock for some developers and especially volume builders, because the change from 5 to 6 stars, was bad, but you could take a design, and in order to get it to 6 stars, you had to spend more on insulation. You put in some better performing windows and you got to 6 stars. Sadly, going to 7 stars, this won't work anymore. You can't just take any design, plunk it on the side and hope for the best. In some instances, you might get around by putting in really expensive windows or, making the walls bigger, putting in more insulation, making the rafters bigger and whatnot. But in many cases, it just will not work. So what it means is you kind of have to completely rethink how you do design. And you have to know about passive solar design and how to orient a house on the side. How can you get north light into your living areas that it can actually help to warm up the house in summer? What do you have to do in winter? What do you have to do in summer to keep the heat out? So that are things you can't leave to chance. So like we said before, nowadays, what everyone does is you get your plans done, you get it detailed, you get the energy rating done. You have to change this entire process and get the energy rating done really early on. And I would say, look for a good energy rater and form a relationship with them, because they need to be part of your design or development team. Because ideally, you do a design, you test it with the energy rating. Are we on the right track? And if not, you have to change it and you have to work on it. And one thing, what I often say is, it has several things. If you do a design, the old standard where, you get to the point of the permit, and then what would suddenly happen if you can't get it to 7 stars? What would you do? You tell your clients, or, what would you do with the project if suddenly it's not buildable anymore? As a designer or architect, it would be quite embarrassing to tell suddenly your client, actually, I'm really sorry, what I designed to you is just not doesn't comply with the code. We can't build this. So, you don't want to get to that point. So therefore, you have to rethink your way a little bit on how to design homes.
And I think there's going to be a number of instances where that's actually going to come into place, to be brutally honest. And that north-south facing element is probably one of the big ticket items that is going to determine whether or not you can get that 7-star rating. Because if you don't have that sun alignment, then how and where your heat comes from and where it dissipates to becomes really, really difficult. Now, as strange as this is going to sound, we're talking about construction here, but for any developer that is doing a pure land subdivision and trying to sell as land, you want to start to think about this up front to say, well, I need to align my blocks of land so that the frontage, where humanly possible, is north-south facing. Otherwise, I might not have a saleable product. And on top of that, the kinds of builders that are then going to be building on these blocks, they're, especially things like volume builders where they've got cookie cutter designs where everything is aimed at facing the street. If it's an east-west facing block, that design is almost certainly not going to pass the, 7-star rating. So all of those volume builders are going to have to redo their designs to actually not necessarily have that frontage, that street appeal anymore, because the house has to be kind of pivoted on its orientation.
And the other thing as well is, even if you have, even if you subdivide land, like you said, even if you have north on the side, that actually can work quite well. But you have to make sure that you don't have the garage on that side. Say if you have the long side and north, you could still get it, really nice living areas there. And, you might have your garden to the back, but as long as you can get the north-facing windows on the side, you will be fine. But again, if you have suddenly your driveway and your garage there, you're screwed. Sorry to be blunt, but, that will be very challenging. And then, like you said, with volume builders, at the moment, the volume builders, they have their set homes, they have a home that whatever with a 7-meter street frontage and a 10-meter street frontage, or, whatever the block size is. I think in the past, they really have to rethink, and there is the north-facing block and the west-facing and the south-facing. And you have to be way more creative. And, obviously, it's not always ideal. You might have cases where the north is maybe facing the street, and you don't want your living areas there or something. But then you have to come up with inventive ways. How can we get light in? Can we get highlight windows in? Can we get roof windows? What can we do? But you just can't leave it to chance. Or, if you do it, you either have to spend an absolute fortune on glazing and insulation, or you won't even get a pass.
Yeah, well, we'll talk about some of the impacts of things like glazing and different designs and how to be a little bit more efficient in that. But at the moment, we just want to try and capture what are the things that go into the rating system. So position of the sun is very clear. Insulation, so the kinds of insulation, where it is, that sort of, how does that apply?
Definitely. Obviously you have to put in floor, wall, ceiling insulation. Really important thing is insulating between the garage and the house. I hope it should be obvious by now that you have to do that. And then with the energy rating program, you can test out as well, how does the house perform if I have my normal insulation, say, 2.7 beds for the walls. But in some instances, that might not be enough to get you to 7 stars. But, if you need more insulation, then you have to start to think early on, what are we going to do? Will we have thicker stud walls, or are we actually going to put in whatever insulation between the studs and then another layer externally or internally, which makes your wall thicker? That's things you have to take into account, especially when you're building on tight sides. Again, if you leave that up too late, you might actually struggle then suddenly getting all the rooms or things sorted.
Very good.
Yes, so insulation, then obviously the windows, you put in the windows, and and obviously again, the higher performance the window, the better it is for your star rating. And what I find out of experience with the energy rating, that typically a concrete slab gives you much better rating than a timber subfloor. So usually it almost jumps between half a star or a star going from a timber subfloor to a concrete floor. That's something to keep in mind, that's kind of some easy points. Obviously, ventilation, if you have ceiling fans and like that, that helps. Another thing that gives extra points in the star rating, or the other way around, minus points, is internal toilets or en-suites. So if you have internal bathrooms or en-suites in the house, the energy rating program assumes that each time someone goes in, the light and the fan goes on. and you actually get kind of negative points. So if somehow possible, try to design homes or buildings where all the bathrooms or toilets have some sort of external ventilation. That also helps definitely with the star rating.
Very good. Okay, so now let's start to talk about, so that's us trying to bring it in here in Australia, but you touched on it before. You came here, when was it, 2007, and you were going, well, all of this has been done in Europe for a very, very long period of time. So this isn't new. So what are the trends around the world? What has everyone else done? And what are the lessons we can learn from that we can start to apply here in Australia?
Definitely. Yeah, so I think that is kind of where the passive house standard comes into play, and I'm a huge passive house fan. So I knew about it a long time, and I've been following it along, and then I finally did this course in 2017, and it's almost like Alice and the Little Rabbit. Once you know it, you almost can't unknow it. You can't go back. So the passive house standard is an international voluntary building standard for highly energy efficient and healthy buildings. It was kind of created 1990 in Austria and Germany. And it really, it may sound complicated, and some people think it's rocket science, but it's really just building science. It just goes back to physics and kind of the basics I had already back then at uni, just a bit more whatever mainstreamed or detailed. And what it is, passive house looks at the construction with a fabric first approach. So it takes into account continuous insulation, airtight construction, to minimize thermal bridges, high-performing glazing, and then the important difference is the mechanical ventilation system with heat recovery. So that means there is a system that kind of constantly brings in fresh filtered air, and the incoming air is preheated in winter and pre-cooled in summer, so you don't lose, temperature either. And yeah, it just creates really healthy and sustainable indoor climate. And yeah, it's a whole lot of data around it. I don't want to bore you too much about it. But what I would recommend if someone wants to know the basics, there is actually a fun little video. It's called Passive House in 90 Seconds. If someone wants to Google that, it's quite cool. And the interesting thing is, the word passive house might be misleading. You might think, it's just for houses, so, it's not for me. But actually, house means more like building in German, like a Krankenhaus is a hospital, for instance. So it really applies to all building types everywhere. And while the standard is fairly new-ish in Australia, when I did the course in 2017, I think there were like 11 certified passive houses in Australia. And by now it's 50 something. And again, that might not sound as much, but there are hundreds of projects currently in the certification process. So it's exponentially going up. And obviously there are many, single residentials, but there now is as well social housing. There is a hotel, there is a childcare center, there is a community center. A school is being built at the moment, apartment buildings. So, a lot's happening. But having said that, that's, in Australia, we're still kind of early stages. But in Europe and in the US, it's really taking it by storm. And there are several countries or states that actually have made it mandatory. So if you want to build something or even do an upgrade to a building in New York City, everything has to be to the passive house standard. Similar, I think, in Luxembourg and Belgium. And even Scotland is just introducing a new standard that's equivalent to the passive house standard. So, for everyone thinking out there, that's just a new trend, not to worry about it. I would recommend to rethink it. It's coming worldwide, and it's kind of recognized one of the best pathways to get us to net zero.
And I guess one of the differences, other than the actual efficiency itself of the passive solar design, is as you said before, we're not certifying, I guess, from our 7-star rating, but the passive solar design does, the passive house design does. There is a certification process. So at the end of the build, you have to go and do proof points to actually get the tick. So, so how does that certification process work?
Yep. So with the passive house, if you want to do a passive house, collaboration is kind of key. You have to do kind of much more work up front. You have to create a lot more details. Everything in the construction has to be planned and detailed really to the dot, which to some degree, helps with the quality assurance as well, because most of the problems are, solved early on rather than on site. That takes away a lot of the unpredictable of normal construction. But what it is that at the start of the design process, you do the passive house planning package, which is a calculation tool similar to the energy rating, but way, way more complex. It's kind of a beast of an Excel sheet. I think it's between 30 and 50 tabs where you put in all kinds of data from what insulation you use, but also any appliance and light fixture and whatever goes into your house. So really everything is detailed, looks in much more detail at shading and whatnot. So on the one hand, you have the calculations. Then, like I said, way more details that look at the construction. But then you have the actual quality control or assurance from the builder. So once the houses are done, you do a so-called blower door test, where you pressure test the house and see how actual airtight it is. And just for your reference, so the Australian, the National Construction Code calls for an air tightness change of 10. And so what you have to imagine, the air tightness refers to an air change per hour. So one air change per hour would mean the entire volume within your building is fully exchanged within 1 hour. So the Australian code calls for 10 air changes per hour. So imagine you warm up your house, in winter with heating, and within the 1 hour, the entire air leaks out through gaps 10 times per hour. So that's how leaky our building code is. The passive house standard, on the other hand, looks at an air exchange of 0.6 per hour.
Wow.
So you can see how different it is. On the other hand, like I said before, the houses that have been tested, hundreds of houses in Australia, most of them actually have an air leakage rate between 15 and 20. So, much, much worse than actually what's called for in the building code. Yes, so that's one thing then. Sorry, I'm derailing a bit, but that's one thing then how the builder can, check the air tightness of the home. And that's also how you can get quality assurance that what the builder has done was actually, has done like it was documented. But then if you go one step further, if you go down the certification process, you have an independent third party, a passive house certifier, that scrutinizes all the documentation. So the certifier would look at all the documentation, all the details, all the calculations, the air tightness test from the builder. And the builder also has to provide something almost like a photo love story. So they have to make photos of every single detail on site to show it was actually built as per the construction drawings. That gets all checked by the certifier. And then it goes even one step further. The certifier, which by now we have 4 in Australia, they do the certification, and then everything gets sent to the German Passive House Institute in Germany. And then there is another independent certifier that's scrutinizing everything from the certifier again. So nothing can be missed. And so what happens is really that, what is designed on paper is exactly what you get. There is no guesswork. There's nothing lost in between. And the interesting thing is there was a pilot project in 91 or 93 in an apartment building in Germany. And they did a test just a few years ago, and it performed still exactly as per the original calculations, which I think is quite astounding.
Yeah, absolutely. Now, you mentioned air tightness, and we're going to talk about, I guess, the different elements and different costs, but air tightness is probably one of the best bang for bucks that you're actually going to get. It's a little bit complicated to do, but for the expense that you're actually going to get, the efficiency ratings improvements are massive.
Yeah.
How do you airtight a house? Because I got opening and closing doors and windows and everything. How do I shut that down?
Yes. So the interesting thing is, or rather the sad thing is, the actual energy rating on neighbors doesn't take into account air tightness. So they assume the house is airtight anyway, even though they aren't. So therefore, even if you invest into air tightness of your building, it won't change your energy rating. That's a bit of a sad side factor. But how you do it in reality, there are different ways of air tightness. The easiest thing is that, because plasterboard is already, fairly airtight and concrete is fairly airtight. So what you can do as a first step, you can just caulk and seal, your connections between your plasterboard sheets and between your flooring and your ceiling. and you seal all the penetrations that go through your walls, with sealable tape, we're talking about your wiring, your plumbing, and so on. And if that is done well, you can actually get down the air tightness to between 2 and 5, which is a pretty good result, which is really good compared to the 10 or the 15, 20 that most homes are. But if you want to talk passive house level, that's then where you need to look at the proper air tightness. So either you can use construction materials that are airtight, and we have done a lot of projects with structural insulated panels where the OSB, the external material from the structural insulated panels, they're airtight in itself. That means you only have to seal or tape the joints of your construction panels. That's one way, but the typical way is that there is an airtight membrane at the inside of your home. So you imagine, you have your stud wall, and then you put a layer of this airtight breathable membrane, and then you have to make sure that it's taped everywhere and that you have no gaps. So that is obviously a bit of an adding cost. You're looking at a few $1,000s extra. It's not in the big scope of things. It's not that much. It's a really tiny percentage. And I can't remember the number, but there were some interesting statistics at the Passive House conference this year where someone actually looked into it. And I think the items that make up the energy efficiency of your house or the fabric of your house, it's just between 10 and 20% of your entire build form. All the rest of your build cost goes to something else. And sadly, construction is expensive in Australia. Not energy efficiency is expensive, construction and building in itself. The extra you have to spend to go that extra mile to go a bit more high performing, it's in the big scope of things, it's just a bit more.
It's an incremental cost, and that's probably the key. So, look, we're going to go into some of the elements that are going to, I guess, make a house more energy efficient, and which ones give us our best bang for buck, I guess, when we're looking at how do we do things cost effectively. So probably if we just rattle off a few elements first, and then we can go in and dive into the detail on some of them. So you've talked about the fabric of the house and whether or not we do air tightness and that sort of thing. So glazing, so I guess
glazing is huge.
Absolutely huge. The way that we do ventilation within the house, so whether it's, are we opening the window and just letting everything flow through, or have we got mechanical ventilation inside? Also, I guess, how we are actually doing our heat recovering, how we're doing our heating and our cooling, the systems that we're actually using, all of those go in. Are there any that I've kind of missed there, or?
Shading definitely is a huge thing, especially with our temperatures that, keep going up, or, our hot summers. The important thing really with glazing is you have to make sure that the sun can't hit the glass. So, if you have internal shading, that won't do much. So especially on your western side, you have to make sure that you have some way to protect the glazing. Ideally, minimize glazing on the western wherever you can, but in some instances you can't. Then, make sure there is some way of adjustable shading. That's definitely a huge one.
Yep.
But maybe one thing what I want to just put on in terms of ventilation, like you said before. So when I studied architecture back then in Germany, our building physics professor, he was almost a bit like a Nazi. He's like, oh my God, he was obsessed with ventilating. And he said, oh, you can't have plants inside your house or no animals. They produce too much humidity and so on. He was a bit extreme. But getting to the point of the story, it's something like a 3-person household produces about 8 liters of humidity a day. That's by breathing, eating, showering. And that water needs to go somewhere. And our professor back then had already said, in order to get that humidity out, you need to do twice a day a proper cross ventilation. And by that, I don't mean opening your awning windows or your double hang. That means opening windows or doors on opposite side of your house for 10 or 15 minutes, twice a day. So the reality is that, most days, if it's 5 or 10 degrees outside, or if it's 30 or 40 degrees outside, you will never do that. But the humidity is still there. So, what's going to happen? And mold is this really sneaky, nasty beast that, hides. So typically it can take, and it forms slowly within walls. And often it can be 7 or 10 years until the mold finally comes out. But the sad thing is that mold usually has been growing inside walls for years before you can even see it. Which is one of the reasons we have such a high rate in Australia with asthma and allergies and whatnot, one of the highest in the world, because lots of our homes are really sick. We have mold in them. And therefore, if someone doesn't have a ventilation system, I would just, encourage people to be really, really conscious and try to ventilate. Or even the next step up, what we do with all our projects, we put in some sort of mechanical ventilation system. And there are really good retrofitting options as well. They help you to regulate your indoor temperature, that the house stays warmer for longer, or, cooler in summer. But also you have fresh filtered air in, no pollen. It helps with even with smokes, during the bushfire season and so on. So it's a really good investment. I would recommend to look into it a little bit.
Yeah, and I'm going to pick up on some subtleties that you touched on there. So firstly, we talked about before air tightness, and I guess the fact that means that we don't want air, I guess, leaving and escaping. And then you talk about the opposite of that, to say, well, there's so much humidity that we need to ventilate.
Yes.
So there's the balance between. Otherwise, if we don't get that right, then we might have an energy efficient house, but as you said, mold and fungus and all sorts of things growing on the inside, so not good. Hence why the mechanical, I guess, ventilation side of things, to try and help that out. So that's who's the best person to give us some insights into how to get that balance right.
Yeah, so it's all about controlled ventilation. So one of the things what we typically say in the industry, once you get to an air tightness between 3 or maybe around that, you really seriously need to look at ventilation, or you will cause lots of problems. What we sometimes say to our clients is, you can get little sensors that actually monitor the humidity and CO2 content in your house, because CO2 is another issue. And again, going back to the studies, that the studies had also put in sensors in typical Australian homes and bedrooms to see what is the humidity level and CO2 level. And what was really shocking everyone in the industry, that even those really leaky houses had skyrocketing CO2 levels in bedrooms during the night that were really, really unhealthy. And that was something that almost blew everyone's mind. But our houses are so drafty. How can we have such a big CO2 buildup? Which again can lead to people having headaches, or not getting out of bed and stuff like that. So that's a completely other thing. But so I would just say, it's kind of best practice. Start looking into ventilation, and
Very good. So in order of highest priority, that we touched on a whole bunch of things. So alignment and air tightness and glazing and a whole bunch of things. If you had the number one thing that would actually give you the most amount of points, would it be the alignment of the house? Would that be the biggest one, or would it be air tightness?
Oh God, I guess for the energy rating, it's definitely the alignment of the house and the windows. And look, the windows is such a big topic. I think we have to dive in a bit more. Obviously, now if going to 7 stars, you will need higher performing glazing. You won't get past single glazing, and you will even struggle with the really cheap double glazing. But the thing is, you have to approach it a bit smarter, and you have to get smarter with your glazing location and glazing sizes, and also glazing or door openings. And by that I mean, rather than having floor-to-ceiling windows in every room, potentially the glazing has to be a bit smaller, or you have to come up rather with picture frame windows. So say in your living room, in your dining room, rather than having floor-to-ceiling, maybe have a really nice big picture frame that frames you outside the garden or the view, whatever it is. And that's the good thing with the energy rating, as well as with the Passive House planning package for Passive House. You can actually calculate that, and you can optimize the glazing and look at what performance gives me, what window performance gives me what output in terms of rating. But then when it comes to glazing as well, like I said, for once you have to look at the size, but also at your opening types. Because I know, many people, they just love bifold doors, bifold windows, but they're by far the most expensive type of opening. So, if you really love them, then maybe just reduce them to one in your, hero spot of the house. And similar stacking bifold doors, they cost a fortune as well. They're right behind after the the bifold doors. What's actually quite a bit cheaper is sliding doors. And what we often do in projects is that we have, really big glazing units, say whatever, 4 meter wide, and we have half of it fixed, half of it openable. I'm not sure if you can see much at the back, but that's what I have in my own house here. And that part, costs a lot less than having a stacking sliding door or a bifold door. And I know, many clients say, but, we want to have this big opening, we want to be able to connect with the inside outside. But what I typically tell them to clients is, look, I understand that when they're open, you have it wider open, but most of the time of the year you have them closed. And with the bifold windows, you have all the mullions, that obstruct your view. Versus if you do something like we have here with the big openings, it frames the view more and you have a nicer outlook. So there are pros and cons of that. But then actually the next option down is going to French doors or, hinge doors. And there is actually where the big saving comes into play. So for instance, our glazed door here at the back, it's kind of actually a triple glazed unit, about 4 meters. And I think that door was around $10,000 something, or 10 or 12. That same sized opening, if we would change it to a French door, with some fixed glazing and a French door, would be around $4,500. If we actually were to change it to a really big fixed panel, say 3 meter fixed panel, one door, just to get out into the garden, that would have been $4,000. So there are massive savings. That means, when you do your designs, be a bit smarter on, where will actually be my sliding door, where's my main way out into the garden, and can the other ones be fixed or French doors. And that's how you can reduce your glazing cost a lot. So therefore, it doesn't have to be much more expensive than potentially what you have been doing in the past. It's just a bit of a rethinking on how you use your glazing.
Yeah, so it's not just the size, despite what a lot of people say. Size does matter. So we want smaller openings where humanly possible, and to be considerate of the kind of opening, because in order to get that efficiency, I guess the mechanism in place is I guess really the biggest impact of cost.
Yeah.
Then there's the material that it's made of. You mentioned single, double, and triple glazing.
Yeah.
I think the days of single glazed windows are very limited.
Yeah.
Pretty much everything's going to move to double glazing. People are super worried about the costs of that. Why are you suggesting that that's probably not as big a deal as people are making out?
Yeah, the interesting thing is, once the market changes, and if there's more demand, the market will change, and manufacturers will respond. And what has happened, and similar things have happened in Germany like over 30 years ago, and just happened in California recently. California, they made actually double glazing mandatory a short while ago. And at the beginning, there was a big uproar, similar like here. But then what happened is that all the manufacturers changed, and within a short time, the prices had come down so much that the costing was pretty much the same as single before. And funnily enough, in Germany, double glazing is so cheap. It's actually cheaper than single glazing now, because no one else is producing single glazing anymore. And double glazing is just the norm. And if you go to triple glazing, that's only 5 or 10% more. So it's really a fraction. And then the interesting thing is, for instance, a big window in Germany would only cost maybe $400 or $500, and at the moment, that same suit here, you would pay $2,000 or $3,000, or even $4,000. So there is still a huge difference between that. But like I said, I'm really confident that the market here will shift. Obviously, the other option is to import windows from overseas, and we have done that on several projects. And maybe for a tiny single residence, it might not be worth it because you have the shipping cost and everything on top. But the bigger the project, the more actually relevant it is. And there are great suppliers in Europe, but also some really good ones now in China.
Yeah, and so I think there's probably going to be a transition period where, as the standard starts to come in, and as the manufacturers start to, I guess, cut over to double glazing being the norm, those cost efficiencies are going to come down. But in the meantime, importing is something that we can consider as an alternative, right? So, but in the not too distant future, I'm going to say double glazing is it's pretty much going to be the norm, and the cost of it will, just as we start to mass produce it, will definitely come down. So
it has come down already a lot, and And the thing is, I don't want to name shame or someone, so I'm not going to say brands, but that there is this one manufacturer that pretty much everyone seems to use for double glazed aluminium windows, and they think, oh, they're the best. But I actually find them quite expensive, and their glazing isn't that well performing. And we know quite a few providers that do glazing that perform much, much better and actually cost less. But people just don't know about them yet. So you need to ask the right questions and just know who to talk with in the industry.
So the inside knowledge, just keep
Yes.
that with ourselves. Okay, so what about I guess the next one down the line? Next bang for buck is probably insulation, I'm guessing. So
Yes.
super cheap to actually implement correctly. Are there any? There's lots of different kinds of insulation. Are there any particular types of insulation that are going to get you a better outcome than others?
Not necessarily. I'd say, wall insulation is a bit tricky because obviously if you want to put in more insulation, you have to build thicker walls and that can cost more money. Versus opting extra insulation in the roof on the ceiling can be quite easy. But one thing to keep in mind is that you have to make a height allowance in your plans, especially if you have to go to town planning or DA, you might have to put in some extra allowance for your roof thickness and stuff. Because I've seen people struggle in the past, you got DA and everything through, and then suddenly you need more ceiling insulation, and then you have to lift the roof, and then you have to go back to council, which can be a real nightmare. So, be a bit mindful with that and put maybe some extra allowance for height or so. And otherwise, underslab insulation. Underslab insulation is a huge, huge benefit here in Victoria. Not so much for New South Wales, they don't have to worry about that. But for Victoria, that's, influences the energy rating a lot. But unfortunately, that's still quite a big cost factor.
Yeah, and you did say it earlier in the chat, and people might not have missed it, so I'll loop it back around to it. Insulation between the garage and the building itself. Because the garage is typically roller door, wind gets in, it's not air sealed, and so it is a massive source of leakage. And everyone thinks, well, it's an internal wall technically, but the internal wall is not very well protected from the outside. So just the two walls that typically are going to be your garage to your house, that's important.
It is really important.
Yeah. What about things like heating? Lots of different heating systems and mechanisms out there, or heating and cooling, I should say. What are some insights into what we want to consider there?
Yeah, I think I might step on some people's toes, but I would say get off gas as fast as you can. Not just for environmental reasons, but with gas you always have to supply charge each month, and that will just keep going up. Versus if you get rid of it, there are massive savings down the track anyway. But the thing is, the interesting thing is...
I'd add to that before going too far. If you move to an electric style system, you have the opportunity for solar and battery, and so the cost of actually running it then becomes zero. Exactly. Whereas gas is, whether it's efficient or not is not the point. You're always going to have an ongoing charge irrespective.
Exactly. And the prices will just go up, they will never go down. And so therefore, and the same thing is, ducted gas heating is very inefficient, but if you're taking gas aside from it, it's also very unhealthy, for people struggling with allergies and whatnot. Besides that, many people might not know actually how unhealthy gas cooking is. So there are lots of studies been done and links to asthma and whatnot. So, another reason to stay away from gas. But yet, the more energy efficient your home gets, the less actual heating or cooling input you need. And to some degree, my personal favorite always was hydronic heating. I grew up with hydronic in-slab heating in Germany, and it's just such a beautiful way of heating. But on the other hand, if you have an efficient house, it's an overkill. You actually don't need it. And the hydronic systems are quite expensive to install and, costs a little bit to run. And on top of that, you still need your cooling, because obviously if you have an hydronic heating system, that wouldn't cover your cooling needs. Therefore, what has been proven in the market is that if you put in high-performing split systems, you can cover the little bit of heating that you have and a little bit of cooling that you need. And you just have to put 2 or 3 systems in the house, and that's usually all you need. And like you said, if you have solar panels, the systems run by themselves, and you don't have to worry about any bills anymore.
Yeah, we'll just talk about in-floor heating for a tiny little bit. Just the laws of physics. hot air rises. So if you start with the hot in the slab, then it has to pass past everything and heat it up as it goes. Whereas if you go the other way around, if you've got the heat coming from the top, it's going to collect at the front, at the top first before it actually comes down. So you have to do a lot more heating before you actually physically feel the difference. Because I don't care if the ceiling's cold. I care if I'm sitting in my chair and I'm cold.
Exactly. And that's actually an interesting thing that you bring up. It's about the perception of temperature. So, you know, that the perception of temperature is much more important than the air temperature. Because I think what most people probably have experienced before, you know, you're in your home, you have your ducted heating or whatever blasting, you know, that there's really hot air coming, but you're still cold. You know, no matter how much air is blowing, you have cold fingers, you have cold feet, you don't feel comfortable. And that has to do with the perception of temperature. Because the thing is, if your surfaces in your room are about 4 degrees colder than the air, there's always some sort of draft. So you always feel drafty, you feel cold, you feel uncomfortable. Versus if your, you know, walls are probably insulated, if your windows are, you know, proper performing, and there isn't such a difference, you feel warm and cozy. So, you know, therefore, if you have a high performing home that's 22 degrees, feels much, much nicer than a house that has drafting or single glazing, where your heater is blasting. It's an interesting fact.
Very good. So we've covered all the big ticket items. I guess then there's, we touched on before, there's the getting the tick in the box, which is done at the theoretical level, not necessarily implemented or measured. Now, as a developer, right, I'm trying to keep my costs down as much as humanly possible. And so my incentive is to do this the cheapest humanly possible way. Whereas if I'm an owner, I've got a different incentive. My incentive is that I want it to be more efficient to run over time. And I might spend a little bit more today in order to make sure that I pay less for the property over a long period of time. Where do you think, just in those slightly different approaches, where do you think the developer is going to err versus the owner is going to err? What are the ticket items the developer might lean on that the owner won't?
Yeah, I think an interesting fact is that, you know, we probably all know that the market is a bit in a turmoil at the moment. You know, houses don't sell as much. And I think one thing is, you know, in order to stand out from the crowd as a developer, you probably have to do a bit different, or, you know, you want to stand out and do something different. You know, that's one thing. And the other thing is, I think I mentioned before that more and more homeowners and people are demanding better homes. You know, they're demanding higher performing homes, healthier homes, and so on. So therefore, I think there is a bit an incentive as a developer to do something different, maybe offer something that's not what everyone is doing, you know, stand out a bit from the crowd. But then also, you know, as a developer, obviously you can ask for a bit more money because, you know, the houses are sought after more. And also you should have the benefit then that the houses sell faster and, you know, for a bit of a premium. So I think ultimately, you know, you would still be better off as a developer. But obviously, you have to market it properly, and, you know, have to make sure that you reach the right target market.
Yeah, absolutely. Okay, we might wrap it up by saying that's everything so far we've talked about is brand spanking new homes. What about, I've got an existing home, I want to retrofit it. How complicated is that to try and fix up what is already in place?
Yeah. So I think it depends a little bit. What I typically say is, you know, if you have a building that has good bones, you know, it has the spaces approximately in the right location, you just have to open up a few walls and maybe add some things here and there, you know, go for it. And, you know, it's definitely worth upgrading. But where I almost draw the line is if you have lots of mold in the house, you know, in the building, because even if you can partially patch it up, it probably might come back again and again. You know, that's one red flag. Or if you had to turn the house completely on its head to somehow make it work, you know, you might be better off starting from scratch. In terms of efficiency, it depends on how far you want to go. You know, there are lots of ways how you can upgrade efficiencies from a buildings, you know, with insulation, windows, draft ceiling, and so on. However, if you want to go that full approach with passive house, it can be quite costly. What you have to do is you have to pretty much tear back the house to its bare bones. You know, you have to be able to install an airtight membrane So, you know, that means you have to either take off all the internal lining or all the external lining, and then you're based pretty much just with the bare frame, you know, which obviously is quite a big cost. So I guess it depends on, you know, if you work with heritage buildings, there's obviously no other options, you have to keep it. But I would recommend, you know, if you embark on a renovation extension, get your consultants all lined up early, you know, either someone who can do the passive force calculation, help you optimize it, or an energy rater, and, you know, have all the consultants on board to, you know, make sure that it works. But maybe one important thing what I want to say is that, you know, we really use this calculation program for passive house as a design tool, you know. So not all of our projects go for passive house certification or close to that, but regardless of if it's whatever, a small renovation or a townhouse development, whatever it is, we do the calculations early on at the start, because we can really optimize the insulation levels, the glazing, the shading. The program gives us also some feedback on how big the heating or cooling units need to be. And then with that information, we have much more to talk with the builders. You know, we can get actual feedback then, okay, if we use this and this glazing, what does it mean for the build cost? And then, you know, we can, the client can then make better informed decisions and say, okay, if we go for the cheaper glazing, we have $200 or $300 higher energy bills or something. And then, you know, you can really decide, okay, I want to spend the extra money on glazing or I don't. But, you know, you don't have to make guesses. You can really calculate the options and see which way I want to go.
Very good. So in wrapping all of this up, Simone, if you were to give one key tip to anyone out there wanting to consider all of that, what would be that one tip?
Yeah, definitely use the energy rater, or the energy rater should be your best friend. You know, get them involved early on in the process and look at passive solar design through all your projects. That is a must.
Very good. Well, thank you, Simone. It's been an absolute pleasure. Now, Simone is going to be talking at one of our upcoming events that we run all the way around the country, folks. So we run these events in Brisbane, Sydney, Melbourne, and Adelaide. So for anyone who would like to come to our events, the link is there. They are both physical, so you can physically turn up and participate in the conversations and ask questions live, but we also live stream them all the way around the country. So no matter where you're located, you could be sitting in Brisbane and watching an event in Melbourne, or sitting in Melbourne watching an event in Sydney, or otherwise. But we would love to see we'd love to see everyone out there come to one of our physical events as soon as humanly possible. Simone, it's been an absolute pleasure. So thank you very much for your time. And I can't wait to see, I guess, the presentation that you actually do live for us in the not too distant future. So
yes, sounds great. Thanks so much.
Bye for now.